Good evening, all of you. And at the outset, I would like to thank Wimble and Professor Jha for inviting me, and also Liberty Institute for funding this kind of thing. Of course, as Rajiv has already mentioned, that there is a critical mass already in place at IIT Kanpur, where we are trying to club our energies together to really scientifically tease out the effects of climate change in different areas in which we have our own expertise, and then have interdisciplinary research so that something meaningful comes out of it. And it's just not increasing the list of publications only. So I'm presenting a very simple study that we carried out, and my slides are not as much loaded as Dr. Tripaঠি's, but the work that I'm presenting was done by our joint student with Dr. Tripathi, first PhD student. And so she had both climate and health component in her thesis, probably for the first time in India. And I'm discussing some of the results from her thesis. This idea came into the mind when obviously everyone has their own first, as you are traveling from the railway station to the campus for the first time in Kanpur, and you see all those kind of images and various kind of things just happen in your mind. And this was, again, I was traveling on 12th of June. It was a bright summer, and I saw a lot of things, of course, solid waste and poor people working. And I also saw at the gate a bunch of IT kids doing their serving with some instruments. And I was really touched that, okay, so students still have this passion. Maybe because of compulsion, they are doing their work in that harsh summer conditions. So that's how this thing originated, that what is the typical exposure levels, or what is the kind of air that a typical IIT Kanpur students breathe. Either they are sitting in their hostels, in a classroom, going for a movie. At that time, of course, Gurudev was more popular than Rave 3, or Rave Moti now, or maybe Z Square. And then what kind of exposure episodes which might come, even for short duration with different time activities. So that was the whole concept behind this kind of study. So I'll take you all through this, and again I'm just presenting the snapshots. So just the basic, we have a myriad of sources through which air pollution, what we really breathe, are created. Of course, they undergo a lot of secondary formulations or transformation as they undergo a lot of photochemical oxidation, and they interact with each other. So what we really get is the ambient air pollution. Of course, it has human exposure and health effects. It has climate change, which has been covered in the last session, so I'll be talking about this, more specific to what we measured at IIT Kanpur and in the vicinity of the campus. Of course, the motivation, or from the history point of view, there have been major episodes as far as human health and air pollution has been concerned. So 1952, London smog happened. This was, again, as the destiny had it, it was not only elevated levels of sulfur dioxide and smoke because of the industrialization taking place, but also because of the harsh meteorological conditions which produced a lot of stable atmosphere and dense fog, which coupled with the air pollution episodes, people who were like really breathing these high levels, I'm like, look at the units, these are in milligram per meter cube. Most of the ambient standards are set in microgram per meter cube. So these were really like putting a bunch of people inside a smog chamber, or like the torturous camps which Hitler is infamous for. And then, of course, people who were suffering from respiratory or cardiovascular diseases and didn't had much shelter from these kind of smoke. There was an immediate death of the order of thousands level, and then subsequent, because of these diseases, again maybe 6 or 7 times higher than that. So just comparing with World Trade Center, which had like 3,000 people dying in one instance, this was also a very significant event. Now coming back to what we are been hearing about aerosols. So out of these various air pollutant, particulate matter is considered to be most toxic. Of course, you can have like biological or chemical agents in form of gases or nuclear radiations, which can be more toxic and could be fatal. But from long-term perspective, these are the particles which can range from nanoparticle all the way to a micron or several hundred microns, which can be inhaled by us, and they are originating from different sources. They can get deposited in different parts of our respiratory system. So if there are bigger particles, probably the human body will take care of them. So particles above 10 micron will be struck in the nasal hair or in the trachea itself, in the larynx or pharynx, and they can be actually taken out by the ciliary mechanism and put it in the digestive system and excreted out without having any problem to the human body. But smaller particles can actually penetrate deeper into the lungs, and the nanoparticles have been shown to actually cross the alveolar membrane and go into the blood. And that's how even cardiovascular or heart diseases are related to air pollution. Of course, there have been several studies going along around the world where they have also pinpointing on certain chemical components in terms of toxic metals like iron, zinc, vanadium, and nickel coming on from exhaust of vehicles or from other industrial sources, or polyaromatic hydrocarbons, which again coming from combustion sources could be as novel as a simple chulha, like in a rural area, or could be more sophisticated and could be coming out from like a BMW. But these have not only like carcinogenic effect, they also have tetragenic effects. Now coming back to the key objectives, as I already gave you the background that we really wanted to see for a cohort, or basically a bunch of IIT Kanpur students who have similar class activity during the semester, and we had bunch of instruments. These were real-time instruments, which I'll show you in a little while, to measure their personal exposure, as well as asking them to maintain a time activity diary, that what time to what time they spent in the classroom, what time was during the transit, what time they were at basketball ground versus what time they were at a temple or they were at coffee shop, and so on. And to maintain this exposure information with the time activity and really try to tease out the measurement and tag them basically, and do this on 2 different seasons, so to get a relationship, if any, with the episodic pollution levels with the deteriorating lung functions. So again, measure like a chart, like on a broad perspective, the exposure analysis is usually carried out using personal monitoring, which was carried out in this study, as well as you can also do stationary ambient monitoring and have a time activity information. You club them together to really find out what are the risks from individual pollutant for a group of students. So both these approaches were tried together. These were the tools we used. So measuring particulate real time from all the way from 300 nanometer to 10 micron, condensation particle counter to really measure the concentration of nanoparticles, so ranging from 10 nanometer all the way to 1000 nanometer, multi-gas monitor to measure real-time concentration of carbon monoxide, NOx, and volatile organic compound, and then a spiro bank basically to measure the lung function, the respiratory functions of a individual. So there were various kind of sampling which were carried out, 1 hour in different microenvironments. There were continuous monitoring carried out during the trips outside the campus. There were also 24-hour personal exposure carried out by the students. So different indoor microenvironments were classroom, computer lab, mess, TV room, restaurant, Xerox copy shop in Shopsy. Then outdoor trips were railway station, open marketplace, shopping mall, movie hall, Regency hospital, and so on. This is how the typical map of IIT Kanpur looks like. So we have the IIT gate here. The marked positions are where the sampling was carried out in different parts of the year. Several times these spots were checked for sampling. This was the old scheme of the cohort. So we had 22 subjects, that means 22 students which were going through the routine classes. So they had similar class schedules because they were belonging to a particular batch, out of which 18 were found to be healthy. 3 were dropped out because they were found to be smokers. So since we are measuring respiratory lung function, so we didn't want to confound them, and we dropped them out. 1 was asthmatic, So that student was also screened out, although we do have the data, but we didn't include it for the analysis. So what we did was a bunch of instruments were packed in a backpack, and they were given to the first individual 7 o'clock in the morning. He or she carried out the daily activities, and at 7 p.m. in the evening, and during all this time, a time activity diary was also maintained by the student wherever that student was going. So initial and final timings were recorded. And if there was some unusual activity, like if that person was bicycling down from hostel to academic area, and there was a heavy truck or something was passing by, that was also recorded to the extent possible. Then at 7 p.m., the volunteers took out the instrument, downloaded the data, recharged the batteries, and cleaned the filters. And next morning, 7 o'clock, again the next participant got this bag to be carried out for the 12 hours duration. And this was done from Monday to Friday. On the weekends, the same set of instrument was kept in the room of one of the participants to be just recording the Saturday, Sunday event. So because we expect weekends to be quite different in terms of the activity as far as the exposure is concerned. And the whole study was carried out for 18 subjects. So basically we had 18 days of data plus weekends in between. And this was carried on 2 different seasons: pre-monsoon, before monsoon period, and post-monsoon during the winter season. For all the subjects, lung parameters was carried out twice. So before the study, after the study, in both the seasons. So we had 4 data set for each student. The idea here was to treat each individual as the control itself. That is the beauty of time series, that you are not comparing 2 different individuals. Whatever I am breathing in summer versus whatever I am breathing in winter, my activities are pretty much same in an academic area, but the only difference is the kind of pollution levels which are present, of course coupled with the seasonal parameters in winter versus summer, and how it is affecting my health. So this is how a typical backpack looked like. So we had all the instrument packed inside. Of course, the sampling probes were brought near the breathing zone of the student, so that they are capturing exactly what the student might be breathing. For outdoor trips, we had like a trolley system in which things were kept, so that we could drag the trolley and the student can take it to say a shopping mall and things like that. It also had a temperature and RH measurement, which was toggled to give every 10 seconds these kind of values. And these are just snapshots. Basically what we have are number concentration on a log scale and the particle size on the x-axis. What these pictures are showing, that in a dining hall versus a TV room versus a campus restaurant versus a photocopier shop, the effect of both activity and the time at which the student was going there. Of course, these are averaged over several values, several different days of data, but the important points which like stand out are because of higher number of students or because of higher activity, you do have coarse particle resuspension, either from the floor itself or from the carpeted areas in the campus restaurant. These were typically taken in the tutorial class, and you do see huge amount of variability. So what typically the way we analyzed the thing was, as soon as the student enter into the class, there's a high concentration levels, and the students keep pouring in after 5 or 6, 7 or 10 minutes with the start of the lecture. The concentration goes down to the background level, and again, like depending on the proximity of the student to the chalkboard, if that is being used, you do have the variation in the fine particle and coarse particle taking place. So that was very well captured, and based on the comments that we found, that lecture hall, the lecture hall which are actually air conditioned have much lower concentration of particulate matter, because AC kind of cleans some of the particles. So if we have a tutorial block which is almost having a good ventilation system with outside, you do have almost the same background levels plus whatever is generated by the chalk. Whereas inside the lecture halls which are properly air conditioned, the air conditioning system kind of screens out to a large degree. So almost like reduction of 60 to 70% of the background particle matter taking place. This is how the exponential decrease in the concentration takes place if you are moving away from a construction source. So there was a construction going on near Hall 8 at that time, and probably like hall 9 or hall 10 was being constructed. So the depending on the student's proximity to that source, we did this exercise several times, you do see an exponential decrease. So if you are very close to the construction site, of course, even for a 10 minutes you are there, your exposure levels could be as high as anyone who is spending like maybe a whole day trip near Bada or something like that. So these are some of the interesting plots we wanted to show. Although these are snapshots, but several such trips were made to different places. So this shows the railway station trip starting from 9:30 from the campus. You do see peaks in different concentration which are tagged. So as soon as the students leave the campus and goes to a traffic junction at IIT gate, you see higher concentration of carbon monoxide. There are peaks of NO2 also coming up, and you do see like ultrafine particles also going up. Of course, IIT Kanpur, the railway station at Kanpur is completely electric. There is no diesel vehicle coming because it. So we were little surprised why we had this peaks coming during the coming of the trains and going by. And later on, the student found out that they do regular checking of some of the ports where they use some mechanism in which diesel generators are used. So these are portable gensets which they go and check the different engines and different components, and they were probably responsible for these peaks for nanoparticles, which we typically expect from diesel vehicles. Now another snapshot from Rave Moti. An interesting thing was in none of the other places we saw volatile organic compound to be in huge range, only in Rave Moti. And again we tried to find out, and we saw that they were using terpene based solution to mop the floors quite often. So they were like generating these volatile organic compounds, and probably if they interact with the photochemical agent, they will form nanoparticles and so on. Similarly, this was a trip to Bithur and Sai Temple, and you do see that different kind of things happening. And of course, people may ask like, what is the relevance of this? Because this is just one day event, and if you go next day, it could be quite different. But then the idea was to just get a snapshot, okay? So even a small event like brooming in your room or burning an incense for 5 minutes will give you enough exposure, which could be in comparison to that exposure, the whole day exposure on road could be quite minuscule. So that is the idea why we have increasing cases of asthma and allergy inside the campus, especially with the smaller kids, because we are unknowingly or knowingly we are using certain things, or we are spending more time in certain environments which might be affecting their health. So this was at Regency Hospital. We had a tough time to go to the health center because Dr. Nirmal Kumar just shouted at one of the students and he was sent back. But that's the beauty of it. You can sample in GSVM, you can sample in Regency, you cannot sample in our own health center. No, I did. Anyway, he was thinking that I am doing some bioaerosols and bioallergens and things like that, and some infectious diseases could have been that. Anyway, so our Indian standards for PM10 is 100 microgram per meter cube. That is the maximum permissible limit. For PM2.5 is 65 microgram per meter cube. Whereas we see that a bunch of location you have higher concentration. Of course, these are averaged out for several hours and for several trips. So you do, I have not put the standard deviation, but you do see some variability. What I really wanted to point out that if you are in proximity of construction site, or you are in a hostel dining area also, you are exposing yourself to pretty high concentrations. Okay, that could be a short duration, maybe just a half an hour or 1 hour, but this just gives a snapshot basically. Again, this is a 24-hour study for a student. This was from pre-monsoon for same subject. In post-monsoon, we had different parameters, and of course the data for, okay, great. So we have the data for one of them tells the effect of really small particles, that is how open your bronchioles are, like the smallest airways that we have. If there is some obstruction, then you will get a value for that lung function much lower than the expected for a healthy individual. Okay, that means on a statistical scale much significant. Whereas other two parameters talk more about your lung capacity in general, like how much amount of air if I force to breathe in and then force to breathe out, Then the difference of that basically, that is what. So this is a regular breathing pattern. So if I force myself to breathe in a lot of, this is the maximum capacity I can breathe in, and then if I really force out my lungs out, this is the maximum I can breathe out. There will be some threshold value which will still remain, the amount of air. Okay, for a healthy individual, this is what you expect, that the variation will be between 80%. So there could be 20% reduction at the max, depending on how uneasy or maybe like ineffective that measurement is, like, or you do it for 2 or 3 times so that person is comfortable breathing in and breathing out and the instrument is really measuring well. But on a statistical scale, we found that out of the 3 parameters, 2 was significantly different. That means during the summertime, the lung functions were much lower compared to what they were for the winter time. Again, we are not comparing one person to another. It's the same person who is breathing in and breathing out in summer versus winter, and we are saying summer is bad for his or her health. And the main reason, which again we are relating to coarse particle concentration, that in Kanpur we do get a lot of dust storms just before the monsoon, and which increases the background level of coarse particles. Again, we have the data, and it was statistically significant. The p-values are much lower. 0.05 is considered to be the threshold. Here you get 0.002. Then again, somebody will say, okay, you had just 18 cohort, like 18 student, but the status was not carried out on a 18 student. It was like we had 400 hours of personal exposure data. So statistically, it was a good data set. Of course, these are all healthy individuals in the range of 18 to 25 years. So again, like there are issues, but this is very interesting. We were not expecting that to have happened. The other possibility which could have happened is like during the summertime, if there are some bioaerosols, which again have their seasonal pattern, like depending on the temperature and RH and the wind conditions, they may be coming from different sources. So that may be another confounding factor which we really have to see. If we had not measured in our study, but that could have been one of the reasons. So I come to the acknowledgement. Of course, DST Fast Track was the funding agency, and Jaydevi was a PhD student who has submitted her thesis. Rajmal and Shifali were my past MTech students. So thank you very much.